In this video, I'm going to give you a quick review of G-Power, which is a free software program that can basically tell you what your minimum sample size should be for any given statistics test. It does a lot of stuff. First of all, let me tell you that the G-Power software program is an amazing piece of work and it's free. So let's get on with this real quick. So here's the G-Power, and there's their little logo there. And this is what it said under the help. But now it says version 3.196. The one we're really using is 3.197, but this is what came out from this one. You'll notice the copyright is over. But anyway, let's keep going. This is who's putting it out. This is the University of Dusseldorf. It's in Germany, and it's from their psychology department. And HHU is, I believe that's the initials of the real school's name. It's like, I can't pronounce it, it's German, but it's first name H, second name H, and then they use university. And here's a link where you can get it for free. I suggest you do get it from the university. Other places, you can download it there, but be careful. They're always trying to sell you something, so don't do that. But it's completely free. And hopefully I will remember to put a link down in the description page. We got to remember, for every statistical analysis that we run, whether it's a t-test, an ANOVA, correlation, regression, chi-square test, whatever it is, whatever test we run, we basically look for three things. First of all, is it significant, right? Is the difference between the means significant? Is the relationship between variables significant? If it's not, you're done. Stop. But if it is significant, you have to check the effect size. The effect size is the percent of the variance in whatever you're looking at, the DV or the relationship, the percent of the variance that you can explain. Okay? So the bigger the effect size, the stronger the test, more believable the test. And the last thing you should look at is power. Power, and that's what this video is going to be about. It's going to be a quick one. I'm not going to go into a lot of depth. But power basically means that your test is accurately rejecting the null or failing to reject the null, in the short version there. But let's keep going here. So we're talking about power. Power. I got the power. Power is a calculated statistic, and the values range from 0 to 1. The closer to 0, it is weak. It's a very weak test. Nobody will believe it, even if it is significant. And you do have a healthy effect size. If your power is not strong, then it becomes questionable at best. The closer to 0, the closer to 1 it is, the stronger, more believable the test is. Now, in our science, we call it the sensitivity of a test. So in other words, how sensitive is your statistical analysis at rejecting the null when it's supposed to and not rejecting the null when it's not supposed to? Another definition of power is the probability of rejecting the null hypothesis when it's false. It is also the probability of avoiding a type 2 error. And as you recall, that's when you do not reject the null when you should have. It's also known as the likelihood that any kind of statistical analysis will detect a deviation from the null hypothesis given that one does exist. Okay? And these definitions go on and on and on, and they can be very, very confusing, but they're all pointing in the same direction. You know, how good is your test that you are using? So power is calculated by 1 minus beta, where beta is the chance of making a type 2 error, right? Where you fail to reject the null when you should have. That's what power is. 1 minus the chances of failing to reject the null when you should have. That's called the beta, okay? Beta has many uses in statistics. But I like to explain power like this. This is a general rule of thumb formula. Power is calculated by the sample size. That's the main thing. Power basically measures sample size. But when your sample size goes up, boom, your power goes up. When your effect size goes up, your power goes up. But you as a researcher, there's not a lot you can do about effect size. That's in the data. but you as the researcher can increase the sample size. Okay. Now, if within group error goes up, your power goes down, right? Because they're inversely related. And within group error is the same as within group variance, or it's variance we cannot explain. We want this to go down. If this goes down, if you can shrink your error term, your power will also go up. Okay, that's the 1, 2, 3 ways to increase or decrease power. You don't want to decrease power. You always want to increase power. Now here's the actual formula. This little guy over here looks like a pumpkin. That's a phi. Phi equals n is the sample size. This W is omega squared, which is the effect size. And this down here on the bottom, 1 minus the effect size, that's the error term, right? So let's go back to this guy. Right, sample size times effect size. Sample size times the effect size divided by within group error, and that's what this is, 1 minus that. So that's how you would calculate power in the old days. And you had to look up a number in a table. You would calculate this, which, take you all day long if you weren't using a computer, to calculate the phi, and then you would take that phi number to a power table, and it's got all these crazy weird diagrams that look like S's on there, and it was a difficult task, okay? So, but we're not going to do that. A minimum power that we want, because we're a social science, considered one of the soft sciences, is about 0.8. They give us a little slack here. Now, if we were designing ball bearings for like cars or something, this minimum power would probably be about 0.99999, right? In other words, you could have no mistakes when you're dealing with mechanical things that are easy to measure. What we're trying to measure in social sciences, like depression and anxiety and marital satisfaction or job satisfaction, not exactly easy to use, easy to measure, right? We have to use surveys and that kind of stuff. And I think I'm going to end this video here. So, again, power is how sensitive it is. G-Power is the ultimate software to use it these days. It's free. It's a great product. I'm going to go ahead and make about a half a dozen G-Power analysis to show you how to calculate some minimum sample sizes for the main tests. And I hope that helps. MGZ out.